And also from my side, another warm welcome. So as you've heard over the last 30, 40 minutes, we are introducing several key innovations to support the shift towards more intelligent data handling. And of course, streaming analytics could not be missing from that list. I'm really proud to announce that we are expanding our existing catalog of over 50 blocks with the public preview of 5 new blocks in Analytics Builder. And let me tell you, these aren't just utility updates. They are really designed to help you build smarter, more maintainable models, moving beyond simple monitoring towards really automated investigation and reasoning. Let me quickly run you through the lineup for today. So first, we have a smart function block for custom JavaScript logic. Then we have our core intelligent additions. So an ONNX block, which reintroduces streaming inferencing of traditional AI and machine learning models. And the AI agent block, which brings modern generative AI into your workflows. To manage these flows, we've also added a rate limiter for intelligent traffic control. And finally, a new logger block to improve your debugging experience. So let's have a deeper look at how these new blocks fit into your analytics workflows, starting with the smart function block. Historically, if you wanted to execute, let's say, more advanced logic, you often had to combine either a large number of blocks and wire them together, maybe turning it into, let's say, a bit of a spaghetti on your canvas. And that worked, of course, but as your models were growing, they would also become more difficult to read. Alternatively, you could create a custom block or revert to a custom microservice. But now, with the smart function block, it is changing the game by bringing, how you would say, bringing pro code to the no-code analytics builder canvas. You can now write standard JavaScript directly within a block, while the Analytics Builder framework still handles the visual integration. So that really enhances the value you get in a few ways. First, it's an efficiency gain. Your teams don't need to go into other applications, build custom microservices, don't need to learn a proprietary syntax. They can just use standard JavaScript for things like data formatting or calculations, as we will see in a second. Secondly, it will also act as I would say, a complexity collapser. You can really consolidate blocks into one single node, and in such a way reduce the spaghetti on your canvas and really keep the focus on the high-level logic from input analytics towards output. And finally, you could even see it as a kind of a small logic capsule where you code the complex logic, the brain, into one block and then wire that together towards inputs and outputs and other blocks to really make your analytics come to life. So talking about bringing things to life, let's also, of course, show the real-world use cases where you could employ the smart function block. And the first example is maybe, as you see on the left, a string manipulation. That's something which is not that straightforward with just the regular blocks that you have. And if you would, for example, as it states there, want to extract a machine ID from a complex string, if you would have to do that nowadays, it would be a chain of a few expression blocks with complex commands. But with the new smart function block, it really collapses down to a single function block and a simple one-line function, a one-line JavaScript pattern in that function block. And in such a way result in a really much more cleaner layout. Similarly, if, say, you would want to write some conditional logic, then rather than today having to use various expression blocks and text substitution blocks where your logic is a bit distributed over those various blocks, you can now really collapse that, combine that into a single block with a simple JavaScript switch statement and really combine all of that logic just in one block and make it much more your entire model much more focused on the overall flow, on the overall logic, which makes it then much more readable for everyone else. And a final example relates to what I will be talking in the next slide, which is more around AI and machine learning integration and the typical pre and post processing, which is typically required to ensure that the data models are matching. So I hope with these examples that I quickly went over now, that you can see some of the value that this new block brings. And I really hope that you give it a try, share your feedback with us. Also know that if you want to look at these examples in a bit more detail, and maybe even try them out yourself, there is a more detailed article about these use cases also available on our tech community. Then let's look at a combination now of 3 blocks that really turn streaming analytics actually in what you would say streaming AI. And why is that? Well, let's say often traditional analytics, they tend to act as smoke detectors. So they're great at telling you something is wrong, but they don't tell you why it happened or what to do next. So to fix that, with the new blocks, we are proposing what we would call a 2-expert pattern. And so combining traditional machine learning with agentic AI and really applying both practices in the specific situation where they fit best. So why am I talking about a 2-expert pattern? Well, first we have a watchdog, which is represented by an ONNX block, which you could see as your specialist for traditional AI or machine learning, because it can natively execute a pre-trained machine learning models against the high-speed data streams which are coming into the platform. And then this watchdog only, let's say, barks when it detects an anomaly or a failure, depending on what your model is set out to do. So it really detects complex patterns, and then you know that something went wrong. But then again, the question, like, what do we do about it? And so that's typically then where these days modern generative AI comes in. So the second part of the 2-expert pattern, the investigator. And that's where we now propose an AI agent block that can really take that anomaly detected signal, injects live asset context that we have in the platform into a prompt, and then use that to query an agent, which then returns, for example, a human readable diagnostic file. The third block that I want to talk briefly about is the rate limiter, because on the one hand side you have your watchdog, it detects a failure. It might, for example, show some chattering behavior around a detection threshold. So that's why we also introduce that rate limiter block to, let's say, shield or act as a kind of a traffic cop, suppressing duplicate messages or let's say protecting the downstream agent from spending too much of your budget on unnecessary LLM tokens to keep on invoking an agent whenever something new was detected. Big question is, of course, well, yeah, how does that look then in practice and analytics builder? Well, thanks to those new block additions, this can really become a very clean and simple model. So on the left, you see the 3 input blocks, for example, some key measurements describing your machine status. And then in the middle, the watchdog setup is quite simple. So first, a smart function block, as I just discussed, kind of pre-processing the data to be in the right format, in the right shape for your machine learning model. And then the actual new block, the ONNX block, which is also really easy to configure. All you have to do is point it to the ONNX model, which you've uploaded in the Cumulocity file repository, and then it will be automatically picked up at runtime. At the end, you could have, for example, another smart function for post-processing, but to keep it simple, it's omitted from this example. And then the investigator part, also quite straightforward. So first, you could have kind of a threshold block to identify how sensitive that you want your detection. Then, as I mentioned, the rate limiter block to configure how long subsequent messages should be suppressed until you want a new message to go through again to your AI agent. And then really the core new block, the AI agent manager, which is again quite easy to configure. It's basically referring to an AI agent which you have previously defined in the AI agent manager, as Rahul showed you previously. And then secondary, it's the prompt that you provide towards the AI agent, and which you can then dynamically inject contextual values that you have available in the application as by means of additional variables that you pass through to the model. And then the output can then be output of the AI agent manager block is then, let's say, the output of your AI model. And that can then be passed into, say, an event, an alarm, or an email block, depending on the workflow that you want to deliver. So by combining those blocks, you're not just being smart and detecting failures, but you can really, within Analytics Builder, move towards creating an entire solution that detects as well as explains what happened and, for example, proposes what to do next. And then finally, to wrap up the list of new Analytics Builder blocks, I want to talk about an enhancement in debugging. Today, to see if what is happening inside a model, tapping the wires between blocks with temporary event or measurement blocks has always been the way to do so. And it's a perfect, valid, and effective method, but we also wanted to start the evolution of that option, and with this new block, a logger block. So the goal of the logger block is to still tap the wire between the blocks, but instead of pushing it to events or measurements, we are now routing it towards directly towards the logs. And you can add some custom tags, define the log levels, which then makes it very easy to filter out the logs and really pinpoint exactly where the logic of your model is failing. And maybe the one, just to add, the one thing that I really like about this is that this block is really built to stay. So you don't have to delete it when moving from a validation phase to a live phase. There's included a disable toggle, which you, for example, can map to a parameter, so that at the moment that you move from testing to production, you just have to change that one parameter to off, and you can leave it inside of your model. You don't have to change it. And next time that you would, for example, have to troubleshoot it, you can just start from where you were. So to wrap up this section, I've shown you 5 new blocks, which really represent, I think, a significant step forward in how you can process and act on data in real time. As I mentioned in the beginning, the features are in public preview now, so I would really like to encourage you to try them out in your next project, share your feedback with us, and then we can take them as soon as possible towards general availability.